if data centers were a country, next year they could rank 5th globally in energy consumption. Let that sink in. And here's the reality. A single energy optimization, saving as much as 1,000 people city users in a year, takes a 97-page technical document and 10 weeks of implementation time, well, essentially it's just a single push of a button. Meanwhile, 25% of the most seasoned data center people will retire soon, and data centers built to last 20 to 30 years are now faced with changing server requirements that evolve every 12 months. The gap between data center need and capabilities is staggering. My name is Jasper de Vries. I'm the co-founder of Coolgradient, and we're here to bridge that gap and transform the way data centers are designed and run. Now, we're not here to sell yet again another round of expensive hardware. Instead, we tap into something that data centers already have, and that's their sensor data. Using our perceptive AI platform, we use very precise machine learning models to generate easy-to-follow recommendations that tell users exactly what to do and what the impact will be. It's so intuitive, teams only need 1 hour of training before they unleash the full power of our no-code AI solution. This and our modular automations are our competitive edge, letting data center operators implement optimizations quickly and confidently. No guesswork, no data science degree. Take Declan in Dublin. Under his watch, our platform saved him 40% of his facility's energy and 4 million euros in a single year. That's the impact we make globally. Now, we're only just across dozens of facilities, on average, we save 25% of energy and water consumption and boost the operational productivity by 40%. Now, we're only just covering about 20% of the potential optimizations in a data center today. But if this is the impact we can create now, imagine our impact when we get to 40% or 80% in any data center worldwide. We're not just a product, we're building a trust-based sales organization, partnering with top industry players like Digital Realty and T5. Our team brings decades of experience in building companies and understanding complex systems. Exactly what's needed to drive the industry forward. The market is surging, the need is urgent, and the momentum is real. At Coolgradient, we believe the future of data centers is not just bigger, it's smarter, cleaner, and much more efficient. Thank you.
Thank you very much. Let's start with 2 minutes for the questions of the jury, please, and remind to introduce you, if you don't mind. Thank you.
Hannan, Great Spark, great presentation. Can you please share a little bit more about the business model? Is it SaaS Classic, and a bit more about the traction you have so far?
Yeah, so it now runs in about 50 data centers globally. Our latest data center will probably be Chicago, where we're in Dublin, Frankfurt, Singapore, Melbourne as well. So a few of the names of the customers were already on there. Global Switch, T5, Digital Realty. Last one happens to be one of the biggest data center companies in the world. Our business model is based on a subscription-based fee, and that one is based on the size of the data center. The size is determined by the power capacity.
Thank you.
Mark Daly at Bloomberg. Thanks for the presentation. What's the mechanism by which you're saving energy and water? Is it you identify bad equipment and then it's replaced, or is it just it optimizes the equipment that's already there?
Yeah, we can help replacing to determine which pieces should be replaced. We take all the data from the mechanical and electrical infrastructure, everything from valve openings, floor pressures, temperatures, fan speeds, and we use that to really understand what's going on under what operating conditions. So we really match the operating conditions with the optimal settings in a data center. But 60% in practice, 60% of our optimizations uncover hidden maintenance issues, right? So this is the first thing that we do. We take away the hidden malfunctions, so to say, and then we optimize for the set points, because otherwise we would end up sub-optimizing things.
10 seconds.
Thank you for the presentation. It's Jacob with ABB. A question related to the size of the data centers that you've mentioned, that this is like the basis of the fee that you charge. What are the data center segments, the scale of data centers that you address? Is it like hyperscalers, is it colocation, is it small data centers? And if you address like more than one, how are your algorithms adaptable to those so much different needs of different data center scales and designs?
Yeah, currently, when you look at the data center landscape, there's sort of 3 flavors, the hyperscalers, colocation, and the enterprise. We now focus on the colocation. Most of it, well, 2 reasons. One is everything we save ends up in their pockets, right? So all the benefits end up with them. The other thing is that there's a lot of colocation facilities that have multiple data centers. So it really makes it easy to scale for us. You know, that's also part of our go-to-market strategy, land and expand. So that's why we focus. We are having conversations with hyperscalers and enterprise companies. And I think that's the beauty of this platform. It's agnostic for every data center, whether it's small or big. But right now we have a certain focus. Average data center now is about 15 megawatts, I would say. But our Chicago facility will, I think from the top of my head, will be 40 megawatts.
Okay. We run out of time. Thank you very much, Jasper. Thank you for your presentation. Let's continue and welcome Hannan Happi on stage. He is CEO and co-founder of Exowatt. Here you are. Thank you.
Thank you. Hi, my name is Hannan. I'm the co-founder and CEO of Exowatt. We started Exowatt a few years ago with the idea to help power the AI revolution using sustainable renewable energy. And we set a very aggressive goal for ourselves at the very beginning of the company. We wanted to be able to generate electricity at 1 cent per kilowatt hour, and we started working our way backwards from that goal on. Along the way, we've assembled an amazing team of engineers at our headquarters in Miami. We have PhDs in thermal physics, optics, and many other industries and backgrounds on our team. We're doing our testing and development there, and we've iterated through 50 configurations and architecture designs to come up with a solution that we think can really power the AI revolution sustainably and cost effectively. So really what matters for data centers first and foremost today is time to power. So we have developed a solution that you can actually deploy today, doesn't require technology breakthrough for another 5 to 10 years, and is really scalable. And so the core principle comes back to the modularity of our system that allows us to modularly deploy the solution today and linearly scale it with any project size for any data center. This is a solution that can provide 24/7 round-the-clock power to data centers that are looking for baseload power in a sustainable way, and is something that we manufacture in a factory in the millions, doesn't require on-site construction or long lead times. And lastly, for us in the US, it's made in the US and sourced from raw materials that we have in the US, widely available with no rare earth mineral dependency. Our solution is called the Exowatt P3. It's a modular dispatchable solar energy solution, or round-the-clock solar, to power the AI data centers. It's essentially made of 3 elements. That's why it's called a P3, an optical collection system. That's the lens table you see at the top that captures energy from the sun in form of heat, stores it in a long-duration heat battery for up to 5 days, and then can dispatch that in form of electricity using our built-in modular heat engine. And this is a picture of one of the modules at our site. You can imagine you would add a number of these together to power a data center of different sizes. Since we launched the product to the public, which was late last year, we've been overwhelmed with the demand. So to date, we have close to 90 gigawatt hours of demand backlog, and we're now executing on purchase orders with the largest renewable energy developers in the world. And we have a backlog of hyperscalers and other data centers and operators that we're proud to serve. We've also been very fortunate to have the backing of an amazing group of investors. Sam Altman and Andreessen Horowitz led our seed round, and we recently closed our Series A round, which we'll be announcing in 2 weeks from now. Our ultimate vision and goal is to power World 3.0. That's the world where you have abundant energy and intelligence, and that's where we believe we can unlock human superpowers, and we want to power that with sustainable, renewable energy. I welcome you to join our journey and help us grow and expand our business. Thank you.
Hi, thanks for the presentation. There was lots of investment in solar thermal energy in the last 20, 30 years, and it didn't really pan out super well. What's different from this, and why wasn't this approach taken previously?
Yeah, great question. It fundamentally comes back to modularity. So when you talk about thermodynamic systems, the bigger they are, the better they are. At least on paper, the efficiencies are higher. The problem is when you build very large systems, as everyone knows, construction lead times can become very long, and all these other cost runs that you might have that you didn't expect. And that's really what happened to a lot of solar thermal technologies in the last wave. In principle, they were good technologies, but because of these long lead times and construction lead times, they basically didn't become economically feasible. And by having a modular approach, by building something that you can build in the factory where you have tight cost controls and building it in the millions, the same way solar PV and battery has come down the cost curve using economies of scale, we believe that this is going to have the same trajectory. And we ultimately believe that this technology is going to be cheaper than the equivalent solar PV and batteries, because storing heat fundamentally is cheaper than electricity and is easier in many ways. You don't have degradation, you don't have thermal kind of losses in that sense, or chemical or fire hazards, and that's why we've chosen that approach. And as I said, we've been very focused on the unit economics, so even before we had a technology in mind, we wanted to get to 1 cent per kilowatt hour. So the product you see is a result of many, many iterations, not really because we want to build something around solar thermal, but rather we wanted to build something that can generate electricity at 1 cent per kilowatt hour.
Calder from Arrazabal, just one question. Is a plug-and-play solution?
Sorry, a plant?
Plug-and-play solution.
I don't understand.
You connect directly for the client?
Oh, yeah. So the engine can produce 480 volt free-phase AC power, so you can basically use it as a behind-the-meter off-grid solution, and that's some of the use cases we're doing for AI training or for crypto mining. But also you can connect it to the grid or combine it with other renewable solutions. A very particular use case we have in our backlog is to combine this with other renewable assets like PV and wind, and basically have 6 to 8 hours from the PV and wind asset, and then you get 16 hours of Exowatt, and you get this quasi-dispatchable baseload solution that allows you to kind of reduce your dependency on the grid, do peak shaving, reduce your demand charges, and really have the highest percentage of your sustainable energy to power the data center. Of course.
We run out of time. Thank you very much, Hannan.
Of course.
Okay, let's move on and let's welcome Rudie Nolasco Verweij, CEO. Did I say it right?
Verweij, that's close enough.
Verweij, oh, okay. CEO and co-founder of Incooling BV.
Yes.
Thank you.
AI. You see it all over the Energy Tech Summit today. But at what cost? The data centers combined are using more power than entire countries. And this is getting only worse. One big reason is because of the cooling. Up to 40% of all electricity is used for the cooling of the data center. And the reason is because we're treating it like a giant fridge. Even though the actual heat sources are these tiny chips hidden deep inside the servers. That's where we come in. 7.5 years ago, we started Incooling, a technology originally developed by CERN in Switzerland. We had the chance to revolutionize the data center industry. We knew this was going to be very difficult. The data center industry is notoriously conservative, and for good reasons. If the data center stops, our lives basically stop. So we had to partner up with some of the biggest companies in the world, and I'm glad to say we did. What have we achieved so far? Together, we have developed an innovative solution, a cooling system that's inside the server itself, basically air conditioning for your chip, or chip conditioning, a refrigeration-based, glorified mini-fridge for your chip. We implement it inside the server itself, allowing us to rapidly deploy. Unlike our competitors, we have no modifications needed for the data center. For them, it's cold air in, hot air out, business as usual. But what do you get for all this fancy technology? You get up to 50% increase in application performance. By cooling down the chip, we get more performance out of the chip. Secondly, we can get 40% reduction in energy consumed per task completed. For the right tasks, our cooling solution can supercharge your data center. Next to that, we have extreme flexibility. There's no need for fancy air conditioning, meaning anywhere you want compute, we can deliver it. Think of defense applications outside of a data center. Now, one thing that we see a lot is these last days, a lot of global situations. One thing that makes me sleep a little bit better at night is the fact that no single continent can create chips on their own. And working all over the world, I am very, very glad to see the collaboration today on this stage with all the computing companies, but also on the Energy Summit. And I want you guys to work with us to cool down the planet one server at a time. Thank you.
Thank you very much. We are running 30 seconds ahead of your time, so we will add that to the jury questions.
Fantastic.
Alessandro from Adara Ventures. I had a question. How does the cooling efficiency compare with, let's say, liquid cooling or two-phase liquid cooling?
Yes. So for the right application, we are about half the energy consumed per task. So if you look at water cooling, if you have a closed-loop system, it's not very efficient. The open-loop water cooling, meaning you need to reinvent your data center, have pipes going all the way to the roof, and do that kind of situation, that is more efficient than we are. Our main goal is actually legacy data centers. So think of air-cooled data centers that want to implement next-generation software or hardware, and they can't because there's just not enough cooling available. There is not really a solution that's comparable to us.
Thanks for the presentation. This is Sarhat. So we all know it could take awfully long time to get into actual contracts with some of those large players. So where do you stand on that journey, if you can perhaps summarize, please?
It was a real battle, not easy, but we have already sold to these customers. So for example, ASML, in their data center, we have systems running. AMD, we're working with them. We went through the trouble going through their vendor portals or becoming a certified vendor. Having said that, we're now changing the whole business. So we're actually going to work with the OEMs. So having some talks with the top 3 OEMs, and I'm going to sell through them. That's how I wanted to start, but they rejected me. Now it works, and they love working with us. And of course, the whole industry is upside down with the AI stuff. So realistically, that's the way forward.
It's Jacob, ABB, thank you. As there was a question about you versus liquid cooling, how would you differentiate from other precision direct-to-chip cooling solutions on the market? What makes you different and better? Yeah, we run at up to minus 35 degrees Celsius. There's not a single system out there. So we built the fastest servers in the world, period. Doesn't exist anything better. So that's something that we can do. No free lunch. It costs some money. It's the best tech out there. Thank you.
Thank you very much. Okay, next on stage is Stamatiadis, co-founder and head of power system of Peak Energy. Welcome on stage. Good luck.
Thank you. Hello, everyone. My name is Dio. I'm the co-founder and head of power systems at Peak Energy, a startup based out of San Francisco in the US. Access to the grid is a key part for scaling compute, but all of the cheap and fast access is gone. Developers at both sides of the equation, renewable energy and data centers, they all struggle with cost and speed for connecting to the grid. Traditional engineers really struggle keeping up with the demands of today when it comes to data centers. Yes, they have a lot of expertise, very valuable expertise, but they still rely on legacy tools, manual processes, and spreadsheet calculations. At the same time, consultants, traditional consultants, using their traditional business model, they really lack any incentives to innovate, slowing down key decisions that need to be made in order to connect new data centers and renewable energy projects. The race is on, And it's a race to connect as much as possible, as fast as possible. In order to win, developers need an edge. Imagine getting ahead of the pack with instantly available insights on what's happening on the grid and understanding how your competitors' projects are going to affect your own. Imagine, instead of waiting for weeks or even months for study results, developers getting into utility meetings, already knowing and being fully aware of potential constraints and bringing in with them alternative and innovative solutions like flexibility or grid-enhancing technologies. Developers who have an edge have better data, software, and AI at their fingertips. The peak energy platform gives developers this edge. It provides them with clean, comprehensive, always up-to-date datasets coupled with strong power system automated studies suited specifically to their own view of the world. By leveraging AI and machine learning capabilities, the platform magnifies the traditional grid analysis and helps developers with faster and smarter decisions. Our customers are already getting ahead. We partner with leading data center and renewable energy developers who use our platform and move faster than ever. Our go-to-market strategy is to build our service as a software. It's the new SaaS paradigm. We start by replacing their traditional engineering resources until we've fully automated the analysis and let them self-serve and provide quick answers to their critical questions. I'm running out of time. We have a very strong team that blends power system expertise with software and AI experts, and we have decades of combined experience working with leading organizations like those you see in the slide. Thank you very much. Please reach out if you have more questions.
Thank you for your presentation. I wonder, since your platform and the solution is lean on really old database of utilities, which is not easy to access to, can you share maybe a bit about the process, how you get in that, and already how it's helpful for you?
So are you, just to clarify, you're talking about the database and the data?
Yeah.
Yeah. It is a struggle, right? What we found is that it's actually not that hard to get access to the data, but do something useful with them, right? And that's why we hired actually people who do have a lot of experience on data science, and they've been doing projects like that before, so that we get the utility data, couple them with other sources that that are available out, right? And then combine them so that we can prepare something useful for the specific use case of our customer, right? So yes, indeed, it's a bit out of date and maybe using old technology, but one of the key challenges that we are dealing with is actually making this useful for our users.
Thank you.
Question: how willing are developers? How much willingness is there for them to adopt something similar? How much willingness to pay is there?
Okay, so as I said, our go-to-market strategy is to approach the developers and offer them whatever other consultants or their internal engineering teams are doing, right? That takes us up to, we usually work with them 2-3 months, or sometimes maybe even 4 months, until we have now fully understood their use case and now converting them into a subscription-based model where they can essentially self-serve and ask the same questions that they were asking us. Now they're asking it to the platform. So to answer your questions, 3 to 4 months, and then they are able to fully get on board on our platform. Thank you.
Thank you very much. Okay, let's continue and let's welcome Kwan Isaac-Chan. Yeah. Welcome on stage, Chief Business Officer at Proud.
Thank you.
There you go.
Sorry. Yeah, Good afternoon. My name is Isaac, and the Chief Business Officer of Proud and EPFL spin-off based in Lausanne, Switzerland. I want to echo with Incooling that 30 to 50% of energy actually spent on cooling the device, which is a lot of waste. And at the same time, that the heat problem, not just about the energy, is also impact the yield rate of semiconductor production, like the most advanced 3D packaging technology developed by TSMC. And then traditionally, the traditional solution like copper, aluminum, silicon carbide are not sufficient to dissipate heat at the source quick enough compared to the performance of a thin layer of 300 to 500 nanometer of diamond layer. So our solution is 60% much more reduction on the cooling requirement, and then cut the energy consumption by 40%, and then enable a 5x compute performed in the same energy footprint. And then our business model is IP licensing, wafer sales, and co-development project with different partners. And then our technology is much more scalable and much more efficient than our direct and indirect competitors. So our roadmap this year is actually to have our technology integrated into the chip manufacturer, semi-tool producer, and also chip designer. And then we have a team of 7 people that with a lot of expertise on R&D and commercialized technology in different areas of the world. And then we bootstrap our own company in the last few years by selling the color diamond to the luxury watch brand in Switzerland. So, and at this round, we're looking for 4.5 million to scale our technology and build a better team. So, thank you very much.
Let's go for the questions.
Any question?
How complementary is this with other cooling tech? Like, does it work with air cooling?
So, a very good question. So we are focusing on dissipate the heat from the source, which is on top of the chips, rather than it's not we are complement to the other cooling technology. We make the other cooling technology more compatible and more efficient. This is our goal.
I was wondering how proven is the technology for data center applications? You mentioned that you have a go-to-market in watchmaking. I was wondering, have you already tested the technology in an industrial environment on a computing side?
Yeah, we actually talked with insider from TSMC about what should our focus on. So they tell us we should focus on 12-inch wafer, and also to how to apply our technology on their advanced 3D packaging system. This is what they told us. So we are kind of validate with our potential customer in the market. Yeah.
Thank you. It's Jacob with ABB. Diamond doesn't sound like the cheapest solution, right?
Yeah.
How do you address the cost associated with that?
So very good question. So I would like to clarify that we are not supplying a 200 or 300 microns thickness of diamond. We actually deposit a layer of diamond which is 200 to 500 nanometer on top of the substrate. So that's why we can keep our costs very cheap. But of course, right, the technology to implement in this semiconductor supply chain is still a long way. But we know that we are focused, and also we know we have to build a machine that is fit for the semiconductor supply chain. Thank you.
Thank you very much. Okay. Okay, let's continue and let's welcome Kieran Furlong on stage, CEO and co-founder at Realta Fusion. Welcome.
Thank you very much. Can everyone hear me okay? Great. So yes, buenas tardes a todo. I'm Kieran Furlong, and I'm the CEO and co-founder of Realta Fusion, and we're taking a pragmatic path to commercially competitive fusion energy. I'm just conscious all the presentations we've seen have been about saving energy. We want to get back to those days of cheap, abundant energy. Whether we're mining for precious metals or Bitcoin, powering steam engines or AI-enabled search engines, we have an insatiable appetite for energy, and we're willing to put the entire planet at risk to satisfy that hunger. Renewables are a step in the right direction, but really they're too intermittent. Nuclear fission is just, it's not accepted in many parts of the world. So what that points to is the future energy for humanity will be fusion. By fusing hydrogen isotopes together, we can unleash massive amounts of energy with no carbon emissions, no long-lived radioactive waste, and we can do all of this with an abundant and widely dispersed fuel supply. We've started with a very simple engineering geometry, a cylinder. You can think of it as a plasma pipe, and in there we've got hydrogen isotopes, deuterium and tritium, which we will heat up to very high temperatures and then confine with very powerful high-temperature superconducting magnets. You can think of these essentially as clamps on the end of the plasma pipe, keeping the plasma where it's supposed to be. The fusion will happen in this central region right here. Neutrons will carry the energy, and that will be carried away as thermal energy through a blanket, a fluid flowing along the cylinder. The beauty of this is that it is a completely modular design. So we will just be able to standardize on 3 components, 2 end cells, 1 central cell, and then scale linearly to whatever amount of energy we need. Ideally, this will be between 50 to 500 megawatts, and then when we want to go above 500 megawatts, we will just stack additional units in parallel, and that will get us to grid-scale electricity. However, our go-to-market strategy is actually to avoid the grid. So we're going for behind-the-meter applications, things like industrial processes, but also energy self-sufficient data centers. We believe that we've done our techno-economic analysis, and already with our first-of-a-kind plant, we'll be able to get to cost-competitive economics, back to Dionysios' point around cheap, abundant energy, in data centers of interest like Singapore and Ireland, and ultimately get to that very cost-competitive commercial fusion energy everywhere. So that's really what we're focused on moving forward to. This is one of the reasons why we've had a Microsoft-backed VC fund invest in our company as well. Just last summer, we were able to demonstrate the simplicity of our system. We started up the WHAM experiment with the high-temperature superconducting magnets were delivered, and just 2 weeks later, we had the first plasma, the experiment up and running. So a massive success. We've developed a fantastic team of blending world-class physicists with experienced startup operators. Coastal Ventures led our seed round. We're also one of the few select companies that have been picked by the Department of Energy for their flagship milestone program. We are now raising our Series A. Happy to talk to anyone about that later. But in short, we are designing a cheaper, easier to finance, easier to build, easier to operate, and easier to maintain fusion power plant. And that's why we'll win the fusion energy race. Thank you.
Yeah, if I can have that if you want to. I can hold it if you want to. Thank you.
Thank you for your presentation, and it's refreshing to hear that this solution got into else. I wonder, since fusion is a challenge for almost 60 years, and there's plenty of companies are racing to solve this challenge, what makes you feel confident that your solution will be a different one?
Sure. So 60 years isn't as bad as what the New York Times said about the Wilbur Wright and Orville Wright flyer. Just 3 months before Kitty Hawk, they said, oh, you know, manned-powered flight will be millions of years away. And then it happened. Powered flight was enabled by technologies, adjacent technologies, specifically in that case, the internal combustion engine and energy-dense liquid hydrocarbons. So the oil industry and the automobile, the internal combustion engine, came along right before powered flight. For fusion, we've had major advances in the high-temperature superconducting materials, so now we can make very powerful magnets. And essentially, we're doing magnetic confined fusion, so that really you have to create a magnetic bottle that's strong enough to hold that very, very energetic plasma. So that's one of the main reasons. Another reason, I thought you were going to go with the fusion joke about it being, 20 years in the future and always will be. There's a missing variable in that, which is dollars. So fusion funding was cut drastically in the 1980s, and it's been significantly underfunded since, with most of the funding going to the ITER project in the south of France, which essentially is a giant public works multinational program. So I think those are the two main differences. We have enabling technologies, and we've got private capital coming in to work on the problem.
What's the timeline?
2034 for commercial fusion energy with our technology. I can elaborate if we've got dead air, but.
Back to the previous question, also, like what makes it different from maybe not ITER, but other startups that are also here, like Novatron or
so Novatron's a good example. So they also take a magnetic mirror approach like we have, and so we like that. I think a big difference, is mindset, right? I look at some of the other technologies like stellarators and tokamaks. For those not familiar, these are these huge, big donut-shaped reactors, and I kind of see them as science projects, right? They look like big science. The magnetic mirror that we have, it's a cylindrical linear device. I'm a chemical engineer. I can get my head around that. We can also get a heat exchanger around it. So it's just a simpler engineering approach. It was falling behind in the physics back in the 70s, which is why tokamaks and stellarators kind of got a leap ahead. But we've solved those, and we're now applying the latest generation magnets to those as well.
Thank you.
Okay, I'm sorry, but we run out of time. Thank you very much.
Thank you very much.
Okay, let's go for it, and let's welcome Patrick Flam on stage, CEO at Revterra. Here you are. Break leg.
From all of these wonderful presentations, it should be clear to everyone here how much AI is starting to take off. What's probably a lot less clear to all of you is the sheer amount of infrastructure that's going to be required to power this AI revolution, and how different it is from traditional data centers. On the right, you can see one single GPU running an AI model. It can have power fluctuations that exceed 90% over the course of just milliseconds. Now consider a data center that's running tens, hundreds, or thousands of these GPUs all synchronized to run the same model. We could be talking about tens of megawatts dropping or spiking over the course of just milliseconds. If you have power changes of this magnitude, you introduce all sorts of power quality challenges at a site, including power transients or issues with voltage and frequency. That's where my company's Kinetic stabilizer technology comes into play. We've engineered this drop-in solution to use physical inertia to seamlessly bridge between your power source and your load to ensure that none of these power quality issues cause substantial downtime or outages for the on-site equipment. This technology is protected by 3 separate patents already issued and several more underway globally. Our solution integrates directly in an AC mode at the same exact frequency as both the grid and the GPUs. This means that we can actually offer physically instantaneous power quality services. That's 10 to 15 milliseconds faster than any UPS device on the market today. On top of that, we can also offer customers the ability to operate fully without power electronics. This offers additional cost savings and enhances reliability of the installation drastically. Overall, we're offering a much more effective, cheaper, and easier to integrate solution than any power protection device on the market today. On top of all of that, it's much more environmentally friendly. Our device is expected to be made almost entirely out of recycled steel, which means it will once again be recyclable at the end of its incredibly long lifespan. Very circular and minimized environmental footprint. Since our Series A in 2022, we've gone from engineering and designs on paper all the way to a fully manufactured commercial device that you can see on the top right of this slide. We have 2 customer contracts in place, ready to take delivery as soon as we can, and several other commercial discussions underway right this moment. That shows firm and growing interest in what we're building here. We're starting with AI data centers, but those are not the only customers that have power quality challenges that Revterra can solve. We're also doing various other commercial industrial customers like semiconductor manufacturing, copper wire injection molding, and well beyond. That's where we're going next. We've recently launched a $6 million fundraise effort to help pay for our first several commercial deployments and to gear us up for commercial and manufacturing expansion in the near future. My team has cumulative decades of experience across the energy, manufacturing, and product design space. This makes us the perfect team to deliver this critical solution that customers need today. If you're interested in hearing more or potentially collaborating with Revterra, please come and talk to me after the presentation.
What is the potential downside for having power quality issues, for example, for a data center operator?
The downside to having power quality issues. Yeah, the most serious one is damage to your on-site equipment. If you get a large voltage spike or drop unexpectedly, many of these pieces of sensitive equipment on-site can actually break down, have electrical fire issues, things like this. Obviously, downtime in any capacity for a data center is incredibly costly, so we are the most conservative and reliable way to actually prevent that downtime from happening whatsoever.
So loads of these data centers are being built or are built. What do they do to prevent this already?
Yeah, so the current set of solutions on the market today is primarily devices called UPS or uninterruptible power supplies. Those devices are typically actively controlled devices that rely on things like inverters, converters, switches, active feedback loops. That takes about 10 to 15 milliseconds. Our device is actually passively connected directly through from power source to the GPUs, which means we can actually offer physically instantaneous response times. So right now, their only answers at the moment, by and large, are to overbuild their UPS systems or throttle back computing if this becomes too much of an issue. There are a couple of other solutions that people are starting to look into out there, but we are the most, as I said, simple and physical solution to this exact issue.
Thank you for your presentation. If I read it right, and correct me if I'm wrong, is this some kind of like a flywheel energy storage solutions? It's not a completely new concept, so what makes you different from all the legacy solutions in that space?
Great question. Yes, flywheel-based technology, obviously we've been looking into the idea for decades, if not longer at this point. So we have a new type of bearing that allows us to go much larger. We're starting with a 2 megawatt, 100 kilowatt hour device that's about 3 to 4 times the next largest commercially available system. We're also substantially higher in efficiency, roughly 20 times higher than the next best commercial flywheel. And then also, given that scale up we're able to do, we can actually rotate slower, which is how we're able to accomplish this grid synchronous frequency that I was talking about. So we actually operate at 3,600 RPM for 60 hertz markets, where traditional flywheels would operate at 10,000, 20,000 RPM.
Thank you very much for your presentation, Patrick.
Thank you.
Okay, let's go for our last speech of this round. Mart Duitemeijer, Managing Director, Business Development and Regulatory Affairs in Europe at VEIR.
Thank you.
Welcome, thank you.
All right. I'm going to tell you a story on how VEIR has built 2 solutions that sustainably unlock the growth of high-density data centers. Data centers are at their physical limits. The growth of data centers is at its physical limits, not on chips, but on electricity. Data centers are now being constrained by the amount of power that they can access. And the AI workloads of tomorrow will break our grids as we know it. This is where VEIR finds its origin. Our founders came together from MIT, Breakthrough Energy, Los Alamos National Lab to fix one of the energy transition's most critical challenges, unlocking grid capacity. To do so, they built our first product, a superconducting transmission line, moving 5 to 10 times the capacity of a regular conductor in the same footprint with 0 losses, helping grid operators accelerate the deployment of grid infrastructure. To scale this deployment, they raised their Series A2, and we secured $60 million to build the world's first grid-connected overhead transmission line with superconductors. One of our early use cases was a hyperscaler that was trying to connect to the grid. And in those conversations, we learned something new. Inside the data center, the size of conventional cables and busbar are becoming a limiting factor in the design of the data center. And with server racks exceeding 100 kilowatts, copper-based infrastructure is simply maxing out. So they asked us, can your technology also shrink the power infrastructure inside the data center? Turns out we can. We did a customer-paid technology demonstration. We powered a server rack, and we found that our cables can reduce the size of power infrastructure over 10 times. Now, not does this only reduce construction cost, it also allows you to bring your server racks closer together, which reduces latency, which is key for training AI models. And because our cables are lossless and actively cooled, we reduce the need for cooling and improve energy efficiency. On the back of this breakthrough, we raised our Series B, which was backed by leading strategic investors from both the utility and the data center industry. My name is Mart. I just opened up our European office, and we are looking for early adopters. Hyperscalers, data center operators, utilities, and equipment providers. If you're looking to gain an edge and deploy our technology, I would love to speak to you after. Thank you.
You spoke a lot about the transmission, about the capacity that you can increase with your solution, which is amazing. But can you a little bit share about how it's business effective and how it's economically effective as well compared to copper and other aluminum transmission lines?
Sure. So I will always immediately admit we've never considered superconductors to be 100% of the grid. But we know that in Europe that we have several cases where permitting actually leads to delays up from 5 to 10 years, right? So in 5 to 10% of the grid, if you have a constrained corridor and you need to expand your right-of-way, you can do this directly with a superconductor. So you can do it faster. On top of that, yes, if you put us next to a 110 kV line, we're not going to be competitive, but we push 5 times more power. So if you think about per megawatt mile cost, we do become competitive.
Does this have any limitation in terms of the voltage that you can carry, or can this apply also to, long-range transmission lines or something like that?
Yes, it's a great question. So and it's distinguishing for the data center, for both data center products and for the transmission products, we have no voltage drop. So that means that you can actually go way further distance. So if you think about putting your power blocks outside your data hall, right now you can see in these designs they're always right next to the data hall. We can optimize that space because we can go way further. So we have no limit in distance compared to other superconducting projects.
8 seconds.
Thank you. How do you see your company VEIR against competitor in that space? So what makes you different, more efficient or cheaper or better in any way than other superconductivity players?
Great question. So superconductivity has been mentioned a few times, and now the sector is so small that we want everyone to succeed because that's a proof of market. Given our competitors, there's a few companies doing transmission, but underground. They're making cables. We're the only one that have been able to achieve overhead transmission lines, and that is because of our patent on the cooling system. On the data center side, we know we have competitors that do power blocks to the data hall, but from the electrical room towards the server racks, there have been no other companies that have been achieving these type of products. So, thank you.
Okay, thank you very much.
Cheers.
Thank you, Matt.